Hello students, welcome back to the lecture series of methods of differentiation of functions, and this is the second video of special problems of differentiation, and it is our lecture number 15, and this will be the last lecture of the methods of differentiation of functions. So this is an important video for your different exams, including the ACES final exam. So please concentrate to the class. Let me go through the video. So continuing the previous class, we begin the question number 10 here. So we have a function here given y is equal to, this is the given function. This is our given function, a very big function actually. 1 plus a1 by x minus a1, a2 x by x minus a1, x minus a2, a3 x square by x minus a1, x minus a2, x minus a3. This is our given function, and the question asking for this problem is then to prove that dy dx is equal to y by x into this expression. So we are to prove this for the given function. So in this function we should use logarithm before differentiation, because the function is a big function actually. If you direct differentiate this function, then this answer, to obtain this answer, it will be harder. Therefore we will use some special method to solve this problem, and that is why I am including this problem in this special problems of derivative. So you see the solution first. First of all, we simplify the given function, and we should make this function in a single term by taking just LCMs. But we take LCMs in some particular way. You just notice the problem. First of all, if you take the LCM of this first two, you see the right, I am writing here. So first of all, the term is 1 plus, so let me take another color. So first of all, you see 1 plus a1 by x minus a1, then plus a2x divided by x minus a2, then x minus, not x minus a2, it is x minus a1, then x minus a2 is multiplied with this, then plus it is a3x square divided by x minus a1, that is the all factors, x minus a2 and x minus a3, this one. So after that, if you take LCM in the first two, not on the other terms, just take LCM in the first two. If you take LCM at a time for all the terms, then the calculation will be harder. But if you take LCM in the first two only, it will be easy for calculation. You see here, after taking LCM in this two, you will have x minus a1 plus a1 whole terms divided by x minus a1, you see, and the rest of the terms are remaining same, that is a2x divided by x minus a1 and x minus a2, and this term is also remaining same. You see here, this a2 a1 is cancelled, then from the remaining part you take again LCM from this term and this term, you will get a single term in the numerator. Again the calculated value is taken LCM with the last term, this one, for the last term, and that is why I am taking LCMs here in a particular way. You see the solution first. You see here, this is the expression given, then take LCM from the first two, x minus a1, then it is x minus a1 plus a1, this term are cancelled, and these are remaining same. You see, it will be x by x minus a1 and the terms are remaining same. Now again take LCM between these two, and the LCM will be x minus a1 into x minus a2. So in the numerator it is x into x minus a2 minus plus a2x. Okay, now you see the previous line in the previous screen. you see we have this line. Okay, so in this line you see, if you take LCM between these two terms, this one and this one, the LCM will be x minus a1 into x minus a2. That is the LCM. So after taking LCM in these two, you will see that in the numerator, see in the numerator, this term is multiplied with this, that is x square minus a2x, plus this term is cancelled here, so we have only the term a2x. This a2x is cancelled, plus this result is remaining same and this term is remaining same. Now after cancelling this, you can take LCM among these two terms. So it is x square by the term x minus a1, x minus a2, and a3 x square by this, and among these two you are taking now LCM, and that the LCM is these three terms, x minus a1, x minus a2, and x minus a3. So after taking LCM, you see these two terms will cancelled, is one, and so this x square will multiplied with x minus a3, and that will give us x cube minus a3 x square plus this term a3 x square, because this total term is cancelled with this term. And now you see a3 x square is cancelled, so the remaining term is only y is equal to x cube divided by x minus a1, x minus a2, and x minus a3. So that is our expression now. And to solve this problem, we have to use the logarithm, because if you use logarithm here before differentiation, then it will be very easy to calculate or to find the differentiation of the function. So let me take LCM here. You see, after taking LCM, I am writing here, you see very sincerely, your term was what? Your term was y is equal to, I think it was x cube divided by x minus a1 into x minus a2 into x minus a3. I have written here the direct line, so you try to understand how to obtain that previous line. So if you take log of y here, then by logarithmic property, so it is log of x cube minus log of the denominator, that is x minus a1 into x minus a2 into x minus a3 is the term. Now you see here, this by property, this 3 will come in front of logarithm, that is log of 3 log of x, and these terms will make plus if you separate the logarithm, and by this minus you will get the terms as minus log x minus a1, then again minus log x minus a2, then again minus log x minus a3. So this is the term obtained in this line, you see this line. Okay, so now you take the differentiation of the function with respect to x. So it is very simple. After taking differentiation, log y will convert it to 1 by y, and for y you are to write dy dx. On the right hand side, 3 remaining same. Differentiation of log x is simply 1 by x, minus differentiation of log x minus a1 is 1 by x minus a1, and in the similar way it is 1 by x minus a2, and finally this is 1 by x minus a3 only. Then you have a simple thing, but a special way to calculate this, and the special way is, you see here there are 3 1 by x's here, 3 times of 1 by x. So I am writing here one of the 1 by x with the first factor, with the first term x minus a1. Got my point? With this factor. Actually there are 3 1 by x, 3 times of 1 by x. So one of the 1 by x is written with the first one, then plus second 1 by x is written with the second term, that is x minus a2, this term, and the third 1 by x is taken in the with the third term x minus a3, that is this term. So you see here 1 by x plus 1 by x plus 1 by x is 3 times of 1 by x, then minus x minus a1 minus x minus a2 minus x minus a3 is already there. So we can write in this particular way to get the answer in a easy way. Okay, so then you take separate LCM in the bracketed terms. If you take LCM between these two, then it will have in the numerator that x minus a1 minus x divided by x into x minus a1. If you take LCM in the first two, then plus, if you take LCM here, you will get x minus a2 minus x divided by x into x minus a2. Very simple. Plus here again, if you take LCM, the term will be x minus a3 minus x divided by x into x minus a3. And these positive negative axis cancel here, positive negative axis cancel, and positive negative axis cancel. So we have you see a negative minus a1 minus a2 minus a3, minus can be absorbed by writing like this, a1 by x into a1 minus x, just writing the term x minus a1 as a1 minus x and removing the minus sign. You do this in the remaining part also, that is you write a2 divided by x into a2 minus x here, and plus here also absorbing the minus, you will have a3 divided by x into a3 minus x. So after that you are to take just x common, and then finally we will get the answer. You see, I am erasing this. You see the answer first. You see, differentiating with respect to x, it is the differentiation line. I already taught you that how to differentiate this one. Then separate the terms 1 by x with the three terms with the three terms, and then that means this 3 times of 1 by x, one of the 1 by x is written as this factor, second 1 by x written is this factor, and third 1 by x is written with this factor. And after that you take LCM in this two, then in this two, and then in this two. So very simple. I already told you how I have taken the LCM here. Then you see this negative positive x is cancel, negative positive x is cancel. So then you see 1 by x, this x is common here. So 1 by x is common, and this minus is already absorbed with the factor x minus a1 by writing a1 minus x plus, and here 1 by x is already taken away, and this minus is absorbed with the factor of the denominator, that is it is written in the form of a2 minus x, and plus this one again 1 by x is already taken away, and x minus a3 as well, this minus can be absorbed with this factor, and that can be written as a3 minus x. And finally you see this y can be taken in the numerator of the right hand side. So in the left hand side we will have only dy dx is equal to, on the right side it is y by x into this total term. You see, y by x into this total term. And I think this is the answer for the question. You can verify with the problem given in the previous screen. So I take the next question. This is our question number 11. Y is equal to root x plus 1 by root x, then show that this is the expression. And this is one important question. Actually this problem is included in the question bank provided by the council, and the question is given as y is equal to root x plus 1 by root x, then we are to prove this one. So first of all you see the solution here. From this line I am writing from this line, you see from this line. If you take direct differentiation here, very simple, it will be dy dx equal to root of our function derivative is simply 1 by 2 root x, you know this one. Then plus, what about this? It is actually minus x to the power minus half, so it will be equal to minus 1 by 2 into x to the power minus 3 by 2. That is the differentiation of x to the power minus half. The term is actually x to the power minus half, so it is minus half will come out, x to the power minus half, then minus 1, so ultimately it is x to the power minus 3 by 2. And then you see we can write it is dy dx is already in the left hand side, 1 by 2 root x is already here, minus it is again 1 by 2, and this term can be written as 1 by x root x. You see here how it is 1 by x root x, 1 by x root x. You see here minus already here into it is 1 by x to the power 3 by 2. 1 by x to the power 3 by 2, because power is minus 3 by 2 mean it is 1 by x to the power 3 by 2, and that is obviously minus half is already there. It is obviously x root x, because root x is x to the power half and this power is 1, so half plus 1 is obviously 3 by 2, and that is why I am writing here directly 1 by x root x. Now as you see the solution of the problem in the proof part, you see here in the proof part we need a twice x multiplied with this. So if you take a twice x multiplication with this total expression, in the left hand side we have only 2x dy dx, is not it? 2x dy dx is equal to, here 2 is already cancelled, and x by root x mean you can write x by root x one time, then minus 2 is already taken away, x is already gone, so we have only 1 by root x, is it? And you see actually x by root x is nothing but root x only, because x can be written as root x into root x, so one of the root x will be cancelled, and so the term is remaining only root x minus 1 by root x. This is our expression now, and after this just you are to replace this 1 by root x, value of 1 by root x from this equation, you see, from this equation, what is the term? 1 by root x is equal to simply y minus root x, so just replacing this term by y minus root x, and after that you see this root x, and this root x will make it 2 root x and minus y. Okay, so I am erasing all of these terms, and you see the solution here in a clean window. You see here the solution, y is equal to this one, already I told you. Then dy dx is equal to, it is directly written here 1 by 2 root x and minus half into 1 by x root x. I have written here directly, and how it is 1 by x root x I already discussed with you in the pen paper mode. And you see here we have to take a product by 2x, because in the answer part you see 2x is multiplied with dy dx, so that is why I am taking 2x multiplication here. So by taking LCM also, you this is an extra term, or you can directly take 2x multiplication, but here I am taking by taking LCM on the right hand side and then multiplication. So 2x is taken, this 2x is taken here, so 2 dy dx is equal to, on the right hand side it is root x by root x will be root x, and 1 by root x will be there. Okay, this is x by root x is root x, and it is 1 by root x. Same thing, this way is different, but I already discussed that this twice x dy dx is equal to root x minus 1 by root x in other ways. So you may apply that way, or you may apply this way also. Okay, so after that the last line will be same, that is 1 by root x, this term 1 by root x, value of 1 by root x, you see here 1 by root x will be equal to simply y minus root x, shifting this one y minus root x. So applying that value here, this root over x is there, minus is there, this 1 by root x is replaced by y minus root x, and that is implies left hand side is 2x dy dx already here, this root x and root x will be, this root x will be plus actually, so root x and root x is 2 root x, and this minus y is taken to the left hand side, y is equal to 2 root x, and that is the solution for the question. So next we take another question, number 12. If y is equal to this one, then show that dy dx is equal to this one. This question may also ask for second derivative also, and if second derivative is asked for this question, you see, that means first of all you are to prove dy dx, that will be discussed just after this, root over x square plus a square. This is the result of first derivative. Okay, so this question may ask for an expression of second derivative also. Actually I am discussing that part for the second derivative part. First derivative will be discussed in this screen. So first you see If you want to find the second derivative, first you take whole square on both sides, that is dy dx whole square is equal to, this is n square y divided by x square plus a square. Just to remove this square root sign, actually I am taking whole square here. Then x square plus a square is taken in the left hand side by cross product, that is x square plus a square into dy dx whole square. On the right hand side it is n square y square, it is y square not y, n square y square. Now if you take the second time derivation, then the left hand side will be simply x square plus a square is remaining same. Differentiation of dy dx whole square, the first two will come out, then it will be dy dx, then by chain rule dy dx differentiation, and that is the second derivative of y, that is d2y dx2 only, dx2, then plus differentiation of first one, then second remaining same. The differentiation of x square plus a square, this is 2x only, and it is dy dx. You see it is dy dx whole square is already here, and on the right hand side n square is already there. Y square differentiation is twice y, and for y by chain rule you should write dy dx. Now you see this 2y 2 dy dx, and from here also t dy dx, and from here also 2 dy dx can be cancelled. So what will be the term remained? The term remained here x square plus a square into what? Into d2y dx2, into d2y dx2, plus in the second term 2 and dy dx is cancelled, so we have remaining here x into dy dx. You see that one, x into dy dx only, and on the right hand side the terms remaining n square, and 2 dy dx is already cancelled, so n square y. So this made the proof part of second derivative of the given question. This question can also ask for find dy dx, and hence show that this term, hence show that x square plus a square into d2y dx2 plus x dy dx is equal to n square y, or that n square y can be taken in the left hand side also by taking minus n square y is equal to 0. So that will be that may also be a question for you. You may write in your copy after writing the first derivative. Okay, after writing the first derivative you can write, or you should write the second part as a note in your copy. Okay, so I am erasing that. Now you see the first derivative, and that is very easy. You already, I think you already have done this one. So this is the solution part. First you take the first derivative, that will be n into, you see here it is differentiation is simply dy dx is simply n will come out, and here the term is x plus root over x square plus a square is already here, into what about this one, x derivative is 1 and root over derivative is 1 by 2 root over x square plus a square, and for x square plus a square into derivative will be twice x. Now just simplify it, you will get this answer only. Very simple. So I am erasing this line. You see the solution in a clean skin. You see dy dx is already, I have told how this line is obtained. Then very simple calculation, this n is already here. You see the calculation, very simple calculation. It is you see n is remaining there. This term whole power n minus 1 mean this term whole power n, then this term whole power minus 1 will come in the denominator, into it is 2 and 2 will cancelled out, this 2. So after taking LCM here, this x square plus a square multiplied with this x square plus a square, then plus here x is remaining, and you see here that this numerator x plus root over x square plus a square, and here x plus root over x square plus a square, these two terms will get cancelled. So what are the terms remaining? As well, you see, as well in this term x plus a square plus root over x square plus a square whole to the power n, you see here this term can be replaced by y, this term can be replaced by y. So we write here y only, this term is cancelled, so it is ny divided by this, is not it? The term is simply ny divided by root over x square plus a square. So this is the answer for the question, and I already told you that the question can be asked for the for a second derivative question also, and that result is already I have written in the previous screen in pen paper mode. So you can also copy that part as a note after this. You just write the solution of this question, and then you write a note and write that part of the question for the second derivative only. Okay, so you take the next one. This is our question, and this question is included in your main book in the NCERT part, NCERT book, and I think it is in the miscellaneous. It is in the miscellaneous part. So it is a very simple question, and if you have learned about the determinant chapter, then how to find the value of a determinant. You see, first that how to find the value of a determinant. So if you have determinant like this, you just see here, let I am taking a b c d e f z h I, say this is our determinant. Okay, so how to find the value of a determinant? Before solving this problem, you should know this result. So in case of determinant, to find the value of a determinant, you are to write a into this, a into this, a into you are to leave this row and this column, delete this row and this column, and the remaining part, mean for this one you take the cross product only, that is simply ai minus hf only. Then similarly you take minus b here. Why this minus is coming here, it will be discussed in detail in the chapter determinant. So it is minus b into, again the same thing, you remove this column, that is the column remaining b, and the row remaining b, you eliminate this. So what are the terms now remaining? D, F, Z, I. So take the cross product. So it is di minus zf. It will be di minus zf only. And finally you take plus c into, again this c into, remove this column, mean the column remaining c and the row remaining c, you remove that. So it will be dh minus ze. It will be dh minus ze. So this is the way for finding the derivative of a it is the process of finding the value of a determinant. So now this process or this way will be used in the solution of the question here. The question is this one. Now in the similar manner, I just told you how to expand a determinant. So I am expanding this determinant through the first row. First row mean through the R1 row. R1 mean first row. Will be discussed in the chapter determinant in details. So fx into what? Fx into, you see, fx into this column and this row will be left out. So you will have mc minus bn. I am writing here mc minus bn. Then compulsory minus, now multiplying with zx. So you write zx here into, now just remove or eliminate the column and the row having zx. So we have the terms now L, N, A, C. So we'll get LC minus AN. So I am writing here LC minus AN. In the similar way, now this is compulsory plus HX into, now HX, you just remove the column and row involving HX. So we have now LMAB, and the result is simply LB minus AM. So this is our expanded determinant. Okay, so after that you take the differentiation. You should keep in mind that this all the terms MC minus BN, LC minus AN, LB minus AM, all the terms are constant. Okay, so if you take the differentiation in this line, you will see that dy dx is equal to this one, fx differentiation, that will be simply f dash x, zx differentiation, that will be simply where is the pen? Yes, simply z dash x, and hx differentiation, that is simply h dash x, and the terms, these terms will remain in same because they are constant numbers. So now again you reverse the process, that is you should write again in determinant form, and it is obviously this one. First line will be now, just first line will be changed. This first line will be, that is row 1 will change only, because this time it is f dash x, z dash x and h dash x. So I am writing f dash z dash h dash, and other terms are remaining. Now you see, if you expand this determinant by the above process, you will get the previous line, this one. So this is the solution of the problem. Actually I'm telling you another important thing. Actually, if a determinant is given where all the lines of the determinants are variable, that means in the second line or in the third line there are also variables. So how to differentiate that types of determinants? So I am telling that one. You see here, if you have the terms, if you have the determinant like this, you see, say determinant of, you have the function, say it is fx, zx, say hx, then rx, sx, tx, then ux, vx, wx. Actually what I am telling, I am telling you, if your function is this, now you see in all the lines, in the first row r1, in the second row r2, in the third row r3, all the lines are variables, you see. Having variables mean the first row is a function of r, second row is a function of r, and third row is also a function of r. So in these types of problem where the first, second and third, all the rows or all the columns contains variables, in that case, how to differentiate determinant? In that case you should write dy dx will be equal to du dx is simply, first you differentiate the first line, that is f dash x, z dash x, h dash x, first line differentiation, and the remaining lines mean these terms are remaining same, rx, sx, tx, and then ux, vx and wx. First line differentiation, rest of the two lines will remain same, then plus. Now second line differentiation, rest of the two lines are same, that is the first line will be fx, zx, hx, and then it will be r dash x, it will be s dash x, and this is t dash x. Then the last line is remaining same, ux, vx and wx. Now come to the third row, that is plus determinant of, first two rows are remaining same, that is fx, zx, hx, then rx, sx and hx, sorry, not hx, it is tx, and final line, that is r3 should be differentiated, mean u dash x, v dash x and w dash x. So this is the proper way of differentiation of a determinant. But in the previous question you see, we have the function was like this. In the first line you have the function was fx is equal to, here is the function fx, zx, hx, and this was I think L, M, N, and this was ABC. So if you apply the way just I am discussed with you, then it will be simply equal to determinant of first line differentiation, mean f dash x, z dash x, h dash x, then L, M, N, A, B, C remaining same because those are constant, then plus on the rest of the determinant part, that is the first line fx, zx, hx, then this line will be 0, 0, 0 because all of them are constant. This A, B, C will remain same. In the second determinant I am taking the differentiation of the R2 row, R2, and finally plus again the first two rows are remaining same, that is fx, gx hx, then L, M, N, and this line now 0, 0, 0. And we have a property for determinant that if in a row of a determinant all the elements are 0 in a row or in a column, the value of the determinant is 0. This value is 0 and this total value of the determinant is also 0. So you have the answer, this one. That is the solution of the previous question. So this is actual process of finding the derivative of a determinant. So I am erasing all of this. Let me take the next question. It is also one important question. Actually, this question is asked in your in the CBSE final exam, but so many times. Actually, in the CBSE final exam, the question is asking for dy dx is equal to dy, y is equal to this expression, and dy dx is equal to this is to be proved. But in the CBSE final year, this question is asked for, I think 6-7 times this question is asked, but a slight change is taken in every year. You see that change is here only. The change is in this function, sine inverse 2x root over 1 minus x square. These terms are changed and these first two terms are remaining same, and each year in each year this term is changed by some other functions. This is changed, but these two terms are remaining same. So this question may also ask in your in your final examination also. So that is why this problem is taken as an important question. So you take the solution of the question. So first I am writing this expression now. Now here just take dy dx. In this part, quotient rule will apply. This is logarithm differentiation, and this is sine inverse. We will have to take one substitution here also, because sine inverse of 2x root over 1 minus x square, if you take direct differentiation here, the process will be something tougher. But we will take a simple substitution for the last part. And what will be the substitution? I think you recall that substitution, that if a term contains a square minus x square like terms, then it should be taken as a substitution for x, as x is equal to a sine theta. But here a is 1, so we should take just simply x is equal to a sine theta only. So we have a substitution for that last term as x is equal to sine theta only. Or if you clear the chapter inverse trigonometric function, you may also see the inverse trigonometric function in my channel. Search the playlist and you will get that result, that video also having inverse trigonometric function. And you can see there is a formula for this one, mean sine inverse of 2x minus into root over 1 minus x square is equal to 2 sine inverse x is the formula. And if no condition on x is given, then we should consider the principal branch of the function, and that is why in the principal branch sine inverse of 2x into root over 1 minus x square is equal to simply 2 sine inverse x. But if it is not in principal branch, the result may be some other terms that will be discussed in the chapter inverse trigonometric function, and you can watch that video also by searching the video in my channel. Okay, so you see here I am using direct formula here by writing 2 sine inverse x, and here x to the log 1 minus x square whole to the power half will come out. So I am writing that one. So this is the calculated line, simplified line. This root over mean half, this half is coming here, and this total term can be replaced by 2 sine inverse x. We have so many results for this, for different conditions given on x. But if no condition is given on x, then we should consider it is in the principal branch of the inverse trigonometric function, and in that principal branch the value for sine inverse 2x root over 1 minus x square is 2 sine inverse x only. Okay, so now we should take differentiation. So dy dx will be is equal to, you see the first one, this term, it is a quotient function, so denominator square, then denominator this one into derivative of the numerator. So x differentiation is 1, sine inverse remaining same, plus x remaining same, sine inverse function derivative is 1 by root over 1 minus x square. minus minus this x sin inverse x is already here, that is the numerator, into derivative of the denominator, mean root over function. It is 1 by 2 root over 1 minus x square into, for this 1 minus x square, the derivative is minus 2x only. Okay, so very simple. First denominator into derivative of this numerator, and it is whole term, minus this numerator into derivative of this denominator is this one, then plus derivative of this, plus half is already here, into log function derivative is 1 by 1 minus x square here, into, by chain rule, 1 minus x square differentiation will be equal to minus twice x, then plus this plus come to 2 will remaining same, and derivative of this sine inverse x will be equal to 1 by root over 1 minus x square. So the next line, this line is already written in the previous screen, this line, and the next line you see just completing this product, you see here completing it product, or you may take LCM here, same thing, and here you see this 2 will cancel, this minus will come here, this minus will come here, this 2 is cancelled. Okay, so you take simple calculations, so dy dx, this into this remaining same, plus is here, this will cancelled out because root over 1 minus x square, root over 1 minus x square, so plus x will remain there, this minus is coming here to make it positive, x into x is x square, this sine inverse x is remaining same, and this 2 is already cancelled, and denominator is root over 1 minus x square, and divided by this root and square is cancelled, mean it is simply 1 minus x square, minus this minus is coming here, minus 2 is cancelled, numerator is x, denominator is 1 minus x square only, this plus is already here, this is 2 by root over 1 minus x square. Now again you take LCM in these two terms, and that LCM will come into the denominator also. So this, if you take LCM, then this root 1 minus x square into root 1 minus x square will give us simply 1 minus x square into sine inverse x is already here, then this plus x into this root over 1 minus x square, then plus this term is x square minus x square into sine inverse 1 minus x square, and then this root over 1 minus x square is going to the denominator as this minus is term remaining same, this term remaining same, and you see this term is actually what, this is whole to the power 1 and this is whole to the power half, by combining these two you will get it is whole to the power 3 by 2 only, and also complete this product, it is minus x square sine inverse x, here positive x square sine inverse x will cancelled out, so we have sine inverse x plus x root over this term will remain in this term, and these two terms will remain same. You see the previous line already written here, then complete this product and cancel the common terms, so we have only sine inverse x, and here x root over 1 minus x square, here this term remaining same, and this term is also remaining same, and this is equal to, this is remaining same and this one remaining same, and taking LCM between these two actually, minus this term is cancelled, so it is 1 minus x square root over, so that will multiply with this x, so x into root over 1 minus x square, plus this term is remaining same. Here you see these two terms are positive negative cancel, so we have the term is sine inverse x divided by this term, so it is sine inverse x by this two term combining is 3 by 2 and 2 by root over 1 minus x square. So that is the answer for the question, and if in the question the last term is changed by some other function, then this term will be some different expression, this will remain same. Okay, so this is the solution for the question. So let me take another question. This is our question, and this type of question is also given in your main book also, in example part, miscellaneous part, and in example miscellaneous part I think. So you can see that problem also, but this question is slightly differ from that problem, but the type is same. type is same. So you solve that problem yourself, and I am taking this question. So here, first of all, this 36, you have to see here, 36 is actually 3 to the power 6. It is actually, sorry, 36 is actually 6 square. It is actually 6 square. And here we should modify this function. You just observe here, we should modify this function in this way. In this way, you see, do not write this because I will write the printing or typing version here. Just to understand you, I am writing here. So y is equal to sine inverse of. So what about this 2 to the power x plus 1? The 2 to the power x plus 1 is written as 2 into 2 to the power x. A simple modification needed for solution of this question is here. It is 1 plus 6 to the power x. I think you understood this line, and you see this is equal to sine inverse of. Do not take direct differentiation in this question because that will be very hard, tough calculation. So sine inverse of this 2 is remaining here, and you see we can write it is 6 to the power x divided by 1 plus 6 to the power x, is not it? Because 2 into 2 to the power x into 3 to the power x is actually equal to 2 into 3 whole to the power x, means 6 to the power x. Now you see, if we take this 6 power x as tan theta, a simple simplification, if you take this as tan theta, then what will be the term now? This term will be sine inverse of 2 times of tan theta divided by 1 plus, this is 6 square, not 6, okay, so it is 6 square, you see, 6 square because 36, so 6 square and x is already there, 6 square, so 1 plus this term will be simply tan square theta. It is 6 square, so it is tan square theta. Now you see this bracketed term. What is the bracketed term? Tells us what term? So it is sine inverse of, it is simply sine 2 theta, is not it? We have a formula, 2 tan theta divided by 1 plus tan square is equal to sine 2 theta. Now this sine inverse will eliminate. We have only 2 theta remaining there. Then 2 theta is tan inverse 6 to the power x is the expression, and we take the differentiation in this line. We take the differentiation in this line, not in this line, not in the given line. If you take differentiation here, the calculation will be very tough, but if you take differentiation here, the calculation will be very easy. Okay, so try to solve the question. So first I am erasing this whole thing. Okay, so see the solution. This part is already discussed with you. Okay, this is sine 2 theta because this whole term is sine 2 theta. Then it will be 2 theta only, 2 into, and replacing theta as here you see tan inverse 6 to the power x. So now we have the function y is equal to 2 tan inverse 6 to the power x. So dy dx will be equal to, this 2 is remaining same. Tan inverse function derivative is 1 by 1 plus x square, and what is x here? X is 6 to the power x. So 6 to the power x square into derivative of 6 to the power x. What was the formula for a to the power x? The formula for a to the power x, the formula of derivative of a to the power x, what is the formula? You see, dx of a to the power x is equal to what? It was a to the power x into log of a, and here a is 6 only, so it will be 6 to the power x into log of 6. So I have written that line here, 6 to the power x into log of 6. You see here 6 to the power x into log of 6. Okay, so then you just take the simple simplification. So we have this 2, this 6 to the power x, log 6 divided by 1 plus, this is again 36 to the power x, because 6 square is 36 and to the power x is already here, and this is the solution for the question. So let me take another question. This is one of the problem, and it is also a simple problem actually, but we solve this problem by taking logarithm, because in the base this is the base and this is the power. Base and power has the variable. So therefore we are to take logarithm before differentiation. So you see the process of logarithm. First of all, you take logarithm. So you see first in pen paper mode, you see this one. So after taking logarithm, in the left hand side you will have only log of fx, and on the right hand side you will have a plus b plus 2x in the front of logarithm. Then it will be log of a plus x, and for division it will be minus only log of b plus x. This is the expression now. Now take differentiation. In the left hand side it will be 1 by fx, and by chain rule fx differentiation is f dash x. On the right hand side, first differentiate this, rest of the term remaining same, and then differentiate the second function, remaining the first term same. So I am taking, say, a plus b plus 2x remaining same. Take differentiation of the bracketed, curly bracketed term, that is, it is only 1 by a plus x, then it is 1 by b plus x, and then plus, take the differentiation of the first function, it is simply 2 only, you see, because a, b, these both are constants, so will be 0, and 2x differentiation is 2 only, and the rest of the terms remaining same, in log of a plus x plus, sorry, not plus, b minus log of b plus x. Now just simple calculation. After that we combine these two logarithms, we take LCM in these two, simplify, then we proceed in this way. You see log of taken, differentiating with respect to x is written, then differentiation is also taken, then combining these two logarithms, you see, combining these two logarithms. This two logarithms is actually what? Log of a plus x by b plus x. So we write that one. This fx will get cross product here. So fx whole into, this is nothing but 2 times of, this 2 is already here, 2 times of combining these two logarithms, a plus x by b plus x. Then plus, this term is already here, this term is already here, taking LCM here, and the LCM is a plus x into b plus x. So it will be b plus x minus a minus x. So positive negative x is cancelled, it is the term only b minus a. So you see here the first term is remaining same, plus this is already in the previous screen. So this term is the value of fx, because fx should be replaced here. So this is the expression given in the question as fx. This 2 times of this remaining same, plus it is already here, x is cancelled, so b minus a divided by this total term. Then you put x 0, because you are to prove for f dash 0. So f dash 0 is equal to, it will be a by b, because x is 0, a by b to the power a plus b, x is 0, then 2 times of log, it is also x is 0, so it is simply a by b, and here x is 0, so it is b plus a into b minus a will give us simply b square minus a square by here a into b, and that is the solution. So we finish this video here, and this is the end of our chapter methods of differentiation. In the subsequent classes I'll take the next chapters, that is the Rolle's theorem. Then Rolle's theorem is already in my channel. So Rolle's theorem, then inverse trigonometric functions is already given in my channel, and then integral calculus. I will take some entrance related problems for the chapter inverse trigonometric functions or differentiation, and many more. So you keep in touch with my channel. So thank you very much.